So let's say here in a circuit, if current is already flowing, which is of I0, and how your current will decay over time, so that we need to understand. So in this case, our initial current is I0, and if we will go through this theory and we will come to know that this current will decay over a time as time progress. So in order to understand and from where this current comes, so if you connect this RL with some sort of DC source, so the current will rise. And if you disconnect the source and if you short this RL, so it's like kind of freewheeling stage where the energy stored in the inductor get dissipated into resistor, right? So your current will not suddenly decrease, but it will take some time. So this is the transient, so that we need to understand. Now here current is flowing like this, so positive will be here, negative will be here, positive will be here, and negative will be here. So this is nothing but kind of VR, and this is nothing but kind of VL. Okay, so the series connection of VR plus VL is equal to 0. This equation we can write from applying this. Okay, so current flowing in this loop, so VR plus VL equal to 0. If we have some DC source, so VR plus VL equal to the source voltage. Here we don't have any DC source, so VR plus VL equal to 0. What is VR? VR is nothing but IR, VL equal to L di by dt, and that will be equal to 0. So if I take this IR on the other side, so L di by dt will become minus IR. So if I take this di and this current on the one side, so di over I equal to R over L, because if I take this L on the denominator, into dt and negative, right? And then if I apply integration on both sides, so minus R dt, right? So what is the integration of this? Log I is equal to and then I have to integrate from I0 to I, and here 0 to t. So ln I, then the limits will be like I0 to I, and then because the initial value of current is there already in the circuit, which is I0, so I have to integrate I0 to the I, and here minus R by L into dt. So integration of time is nothing but t. Okay, so what we will have is ln I0 minus ln I minus ln I0 is equal to minus R upon L into t. So this will gives me ln I upon I0 is equal to minus R upon L into t. So if I remove this ln, so on the other side what we will have is e raised to minus R upon L into t. This I is nothing but I0 e raised to minus R upon L into t. This is the final equation. Okay, so when time equal to 0, so e raised to 0 will gives me 1, so I equal to I0 from this graph. And when time becomes infinite, so e raised to minus infinite will gives me 0 current. So at infinite time, as time progress, and at infinite we have 0 current in the circuit, and in between we will find that this current will gradually reduce. Okay, and this dynamics will be governed by this time constant R upon L. If you have a bigger inductor, it would take time to reduce the current. If you have smaller inductor, then the current will reduce in a very small time. So this is all about series RL circuit when we have some initial current into circuit and we don't have any source.